Exactly. So you can look at a model in virtual reality in the field and mark up things that need markup, like this column clashes with that other object or asset which is already there. You could discuss or review different variations of models, all these kind of things.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Gregor Bilhauch, and Gregor is responsible for the cloud strategy at the Geospatial division of Trimble. And today on the podcast we're talking about digital twins, which you might think feels like a bit of a buzzword at this stage, but Gregor does a great job of breaking it down for us, explaining what a digital twin is, what it isn't, and what the enabling factors are, the things that make digital twins possible. So this is a story about digital twins, but we also managed to weave the metaverse into the conversation. Hi Gregor, welcome to the podcast. It's a real pleasure to have you with me here today. We're going to be talking about digital twins, but you are in fact the Geospatial cloud strategist or at Trimble, is that correct?
That would be correct, yes. My focus is on figuring out strategy, how we move to the cloud on the survey and mapping side predominantly.
Maybe we should start the conversation with this. Perhaps you could just take the time to introduce yourself to the audience, maybe explain how you got involved in Geospatial, and then we'll sort of work our way towards digital twins from there.
All right. So my background is actually in forestry. So I've got a degree in forestry. From there, I went to satellite image analysis, which is somewhat related to digital twins, you could say. And through satellite image analysis, we came to scan data or point cloud image analysis. In 2010, the company I worked for, which was a startup based out of Munich, was acquired by Trimble, and that got me into the bigger world of Trimble. I had a 7-year period in the US where I worked in a totally different area, which is rugged handhelds, and now I'm back in Germany, and I'm in a role back in the software world, focusing on cloud and how we at Survey and Mapping essentially define and build out our cloud offerings. And that is connected to digital twins because cloud is a big enabler of digital twins, essentially.
Do you ever miss the days of working with satellite imagery in forestry?
Sometimes, but at the same time, it's also good after 10 years in that world to essentially look at different areas, at the bigger world out there, I would say.
Was that an easy decision to make to move on to something else?
Initially, maybe not, because the environment I came from, or the software I managed, which is eCognition, or what is called eCognition, has a very strong user base and community around it. So that was hard to give up. But at the same time, it also, after a while, it becomes not boring, but it becomes sort of monotonous, I would say, to be in that one world. So looking at the bigger picture was nice.
Yeah, I can totally relate to that. Having said that, though, change is scary, right? Because you become quite specialized. You talked just before about having that relationship to a group of people that are sort of moving in the same direction, and like moving away from those things can be kind of scary, I think.
Yeah, absolutely. It's scary, daunting, but at the same time, it's also thrilling, I would say, to explore totally different worlds. Initially, if you're not an expert and you need to learn a lot and lean on others a lot, that's maybe a bit of a challenge, but it's also good to find out new things.
Completely agree. So the promise of this episode right at the start was it's going to be around digital twins. I think maybe we should start off with how do you define a digital twin? What is it for you?
hmm Well, digital twin essentially is a virtual representation which serves as the real-time digital counterpart of a physical object or asset. That's essentially the Wikipedia definition of a digital twin. And I think it also holds really true for what we are looking at as the definition of a digital twin. The key part in that definition, I would say, is that real-time aspect.
Oh, okay. So I was just about to ask or point out that definition doesn't really speak to the level of detail or resolution that we're seeing in modern day sort of models of reality. But I think as soon as you added the real time part into it, it adds that complexity that I think a lot of us relate to when we think about digital twins. Because otherwise, a digital twin could be run in an Excel spreadsheet.
Exactly. And the real time is the differentiator, and also probably what made the adoption of digital twins in the survey mapping, the construction world slower than, let's say, in the manufacturing world, for example.
I want to move on and talk about some of the stuff that's enabling digital twins because it sounds like that's where you have your background. But I want to sort of poke at this real time aspect. What is real time for you? Is there an industry standard that says real time is within this period, this length of time, at this frequency, or does it depend on what sort of vertical we're talking about?
I would say both vertical and also what phase of the digital twin is used in or what application. So if you think of a construction site in at the time a building is constructed, you might need very close timing or very high level of real time where you want to know what's going on at a construction site at a certain time when it happens. But then when you maintain and operate a building, you might not need to have like a, let's say, a daily update of whether your structure is still in the same shape and condition as the day before. So with that, yeah, I would say it depends on the phase, the application of your digital twin, and certainly also the domain you're in.
Could it also be the case that a digital twin is made up of a lot of different data sources, and that some of those are going to need to be updated on a higher frequency, a higher cadence than others? So when we talk about real time, are we in fact talking about a piece of the model that's being updated in a higher frequency, as opposed to the entire model?
Yeah, absolutely. The area that I'm focusing on, that I'm coming from, is essentially the data collection for digital twins, like laser scanning, drone data, survey data. And this data will be updated for digital twins at, let's say, different intervals or frequencies, very much dependent on what phase your digital twin is in. If it's a building that is in operation, you don't need to scan the building on a daily basis. But if it's a building that's being constructed right now, then you would really need to have a daily, maybe depending on what kind of construction you do, maybe even like an hourly scan of certain areas.
So at the start of the conversation, you mentioned cloud infrastructure being the enabler, things that are enabling the digital twins. And we're talking about real time, we're talking about how we collect that data as well. Maybe we could start here. So what kind of data sources are you seeing out there in the digital twin world today? Are we talking about, because I can imagine drones, for example, scanning things. I can imagine people walking around with handheld scanners, scanning things on a regular basis. I could imagine inputs coming from satellites, from social media updates, from lots of different data sources. What are you seeing in the industry when you think about data that's being used in digital twins and that's being updated on a regular cadence?
Yeah, with my background in the geospatial survey and mapping world, I certainly have a, let's say, a biased angle from the scanning survey data type view. So from a sensor perspective, we're certainly seeing laser scanning sensors, total station, GNSS receiver, like point type data coming in, drone data, aerial data certainly play a part in a digital twin. But then certainly their digital twin also is fueled by a lot of other data. Down the line, when a device or an asset is in operation, IoT plays a huge role, I would say, in feeding data into digital twin and understanding how an asset is used or what state it is in.
When you talk about IoT, are you talking about the sensors perhaps that if we think about a construction site, for example, the sensors that are being used to guide the equipment that's moving around the construction site? Or are you thinking about something completely different?
I was thinking about something different. Certainly, the devices on a construction site would be connected, would deliver IoT type data. But you might also have other, like when you look at a building in operation, you have data such as heating systems, elevators, which present you with information about the state and the use of your building. So this is where I see different types of data coming into a digital twin at different times.
In operation, for example, do you see people measuring the flow in and out of a building or a city, for example? Like, were people traffic moving around through an area? And if so, how are they doing that?
So not my key focus of or area of expertise, but certainly that's something that is being done. Trimble is active on the operation side of buildings as well. Essentially, the use and utilization of buildings is of interest. Understanding what parts of a building are used by people at what time of the day, things like that. On the larger scale, Trimble Transportation certainly is looking at measuring where fleets of trucks are going and tying that back to construction, for example, then Trimble certainly has that information and can use that information about, let's say, concrete trucks entering a job site and being ready to deliver concrete at a certain point in time.
There was a focus on scanning that you were talking about before. Is this still a human driven thing? I'm sure that I have, and the reason I ask this is because vehicles are becoming more and more autonomous. And I know that Trimble has recently done a project, I think it was with Boston Dynamics. Maybe you could start off by explaining what that project was about, like giving us a little bit of insight into to actually what happened, and then perhaps helping us understand how far off being the future is this? Is this still the future, or is this what's happening today?
Yeah, right. I mean, talking about enablers for digital twins, collection technology, and I would say the density of data or the availability of data plays a huge role. And this is where autonomy comes in. Let's say 10 years back, it took a lot of time and physical effort to scan a whole building. Now, the sensors, laser scanners have become easier to use. The data processing is simpler and faster. And that also leads now into autonomy. So Trimble has a close partnership with Boston Dynamics, and there's a product available for purchase right now, which is a laser scanner combined with a robot from Boston Dynamics, which enables you now to essentially one time program the route of the robot on a construction site and then have a repeat scan of that route or the object or construction site you're in, which again helps or facilitates a much higher data density than if you would manually run the scans every night or every morning.
With this level of autonomy, things like this, like it seems like this is going to create more efficiency. So the building is going to get scanned, the smart city is going to get scanned on a regular basis. Whatever it is that we're scanning, we can do it on a regular cadence, and we increase the efficiency of that. So, and oftentimes when we increase efficiency, that inefficiency was someone's job, and and they have to find something else to do. Do you see things like this replacing humans when we think about this kind of work, scanning things? Or is there still some circumstances where, like, okay, this we need a human to do this?
To a degree, there's probably a replacement on the long run going on, but at the same time, it also opens up new opportunities that before weren't feasible. Like I, I don't know of customers that would go every night to scan a building at the moment. So now with that robotic solution, that enables things that weren't basically possible or weren't being considered before. On the long run, looking at autonomy, I would expect that to replace certain job types through autonomous solutions. Like autonomy also, I would say, is a big driver in creating digital twins because in order to run a robot through a certain area, you basically first need a map for the robot. So you scan an area, and then as the next step, the robot can navigate and find a route through that area. So in a way, that's a cycle that you're looking at where you create a map, and then the robot creates basically more maps, and that's again used to improve the ability to navigate certain areas.
So we've been talking about things that enable digital twins. So one of them is this increased resolution of data that we can get, both in the spatial resolution of the data that's being collected and the time frame the data is being collected over. That's where things start, I guess, when we think about making digital models, really accurate digital models of the world. I guess what we need to do now is to bring that data together. Can you talk to me a little bit about what the enablers are there? And I'm guessing a lot of it is going to revolve around cloud native geospatial formats and compute and storage and those kind of things. Am I right?
Yeah, absolutely. So other than data or collection technology, I would say the other topics that I've got mentally listed are basically the data transmission, the storage technology, the processing technology, as well as the visualization. Now, if we look at transmission, being able to upload large amounts of data, have devices connected to the cloud is something that makes it possible to have a more real-time update of data and also to reduce the complexity about getting data, making data shareable or making data accessible. When it comes to storage technology, again, the complexity for an end user of a digital twin is drastically reduced by having data in the cloud because you don't have to run a data center. You can essentially buy a solution and have your whole digital twin hosted in a solution or in an environment that's built and optimized for that kind of job.
That's interesting talking about hosting the model. I mean, in a lot of ways it makes sense, but when we think about in a distributed world where data could be anywhere in particular, I guess the first place my brain went to was that the digital twin would sort of come into being in the client itself, as opposed to being hosted in one centralized database.
I think the central hosting of digital twin or data in general has a lot of opportunities and a lot of advantages because it will allow collaboration on that data very efficiently by parties that are not necessarily co-located, and it also reduces the complexity on managing and maintaining that kind of data quite substantially.
So a lot of these cloud native enablers that I see are also the formats, the streamable data formats. When we think about digital twins, is there a format for a digital twin, like a standardized format for a digital twin, or is anyone working towards that at the moment?
There is work going on towards standardizing formats. I'm not aware, or we haven't seen a digital twin format yet. There are probably formats for different types of data that are optimized for digital twins, like IFC for BIM data, different versions of cloud optimized point cloud data, for example. But that would be, let's say, cloud optimized data formats for specific data types. Bringing it all together in the digital twin is then still down to the individual supplier or companies at the moment, and that's where Trimble's working on, where other companies are working on for sure.
In the data collection chain, it seems to me that the data will be collected in perhaps a geospatial format and then moved, streamed to a central hub, like you were talking about, maybe a centralized data model in the cloud somewhere. Are we then converting it to something like BIM data into a CAD format there? Or is that happening somewhere else? Because it seems to me that the geospatial world, the GIS world, is quite different in terms of the data formats that we use and that we collect in to the computer aided design world, the BIM world.
Yeah, absolutely. If you collect a point cloud, the end user isn't necessarily interested in the point cloud per se. It's a quite complex data format, data type, or data information. What the actual interest is being able to identify, let's say, walls, floor, objects within that data. Now, the technology that enables digital twins also enables and facilitates automating those kind of transformation or extraction processes, I would say, getting from a point cloud to, let's say, a model or parts of a model, like identifying walls in point clouds, identifying certain assets in satellite imagery, for example.
Okay, so this like it really speaks to the argument for the centralized data point. If we've got huge amounts of data coming in, having a centralized model would mean also that we could have that model right beside the compute that we need to process it to create these features that we're just talking about.
Exactly. Having that data co-located helps leverage the cloud capabilities around machine learning, artificial intelligence, which again is a driver in or an enabler for digital twins.
Okay, so we've talked about the collection side of it. We've talked about streaming it to a central place, the processing, and some of the things we need to think about that there. A little bit of a conversation around some of the formats involved. I guess the next step is to get it out to people. So when you think about this kind of data model, we're getting closer and closer to representing the world the way it actually is. When we think about how we interact with that data, are we still thinking about on a screen, like in a 2D world, or are we thinking more augmented reality, virtual reality? And if so, what kind of clients are you seeing people use out there to interact with the data?
We're essentially seeing all the different formats. There certainly are users that will sit in front of a desktop computer looking at a digital twin, but you also want to be able to take the digital twin to your job site and be able to look at it on an iPad or on your smartphone. And then down the line, ultimately, you also have a lot of benefit to gain from looking at the digital twin in augmented or virtual reality or mixed reality. And Trimble is working with Microsoft HoloLens to drive that technology and quite effectively.
Okay, when you say effectively, does that mean that it's in the market now? Are there people working on building sites that are using this and like gaining insights from it, or are we still talking about the test phase of things?
Trimble has a solution on the market, which is a combination of Microsoft HoloLens with a hard hat that you can take into a job site and collaborate on BIM data in the field, walk through basically the mixed reality around reviewing construction models and discussing changes, clashes, things like that.
Wow. When you say collaborate, what do we do? Like, I'm sorry for asking all these dumb questions. What do you mean when collaborate? Can I edit data? Because I'm assuming I can see it, I can interact with it in some way, I hope. Collaboration, what does that mean for you? Can I edit it in the field? Can I put comments on it? Can I send it to somebody else? Hey, look what I'm looking at. Is this what we mean?
Exactly. So you can look at a model in virtual reality in the field and mark up things that need markup, like this column clashes with that other object or asset which is already there. Um, you could discuss or review different variations of models, all these kind of things.
Wow. Is this the new as-built documentation that people are going to expect in the future to be, delivered with the final product?
I would think it's going that way. And HoloLens is one example which is used, but we also have an outdoor version of that, which is called Sight Vision, which allows you to take the same kind of mixed reality approach into the outdoors, where you have high accuracy position, and then a tablet which overlays the virtual reality with your real reality, and that again allows you to take a look at models in the field, identify if there's any problems, any clashes.
I'm really tempted to use the word metaverse here. Is anyone doing that in the conversations that you have with them?
Absolutely, metaverse is used as an item or a topic here, as it is a big buzzword. We haven't coined any Trimble metaverse product yet. I wouldn't want to do that either. But in conversations, since digital twin is probably a much used buzzword, metaverse is probably the next big buzzword there.
We've been talking about this in terms of a building, but I'm assuming we could use it in terms of a smart city as well. This might be slightly off topic here, but is this the role that we're going to see geospatial playing when we think about the metaverse, creating some of these virtual worlds anyway, or at least augmenting the world we live in today? Through exactly this kind of stuff. So we're talking about collecting the data in these formats that we understand on a regular cadence, so we can represent the world in a realistic way. We're talking about streaming it to somewhere where we can centralize the data and process it, and then we're talking about delivering it to clients as well. Is geospatial? Do you think? It sounds to me anyway. It's going to be the back end for at least some parts of the metaverse.
Absolutely. Maybe not the metaverse as you see it for like a consumer application, but in a professional application, we have clients like SNCF, French Rail, and other big users of scan data who scan whole railway networks, including train stations for entire countries using mobile mapping technology. Now, all of that data goes into central data repositories and is being used basically through the whole life cycle to plan, to collaborate, to streamline facility management. So that in a way is the backbone for that, I would say, yeah, professional metaverse.
I think we've coined a new phrase. I'm tempted to say the word NFT here as well, but I won't. We talked about real time before, and we talked about these different technologies, and I want to sort of move the conversation on a little bit to talking about a few things in the future. But my first question is real time. We talked about real time, and we talked about that it might mean different things depending on where you are in the life cycle of building your model, and the life cycle of your project, and definitely within the vertical that you're working in. So real time might mean different things there. But I'm wondering if we take real time to mean representing the world as it is now and as it's changing in real time. So changes are represented exactly as they're happening, not every hour. Aren't we just creating real time problems for ourselves? Because what human is going to look at that in real time? What human is going to make decisions based on that in real time?
So it depends on the problem you're trying to solve, I would think. If you look at the Trimble office in Christchurch, for example, it has vibration sensors, which are IoT sensors built in. So in this case, it's not like a human would monitor those sensors in real time, but the sensors are still delivering data in real time. And if an earthquake happens, then you still have that real time information of what happens in the building, and have potentially alerts in case of structural issues, but also have then later on a record of what happened in the building. So again, the combination of real time data availability with things like machine learning and the processing technologies in the cloud will allow you to do things that don't require a human being to real time monitor that data.
So not just creating, I think you mentioned walls and doors and floors and things like that when we think about a building, but also making decisions along the way. So what is important here and now to show the end user, for example?
Yeah, absolutely. And again, if you look at the use of digital twins or the opportunities a digital twin offers, it's a lot about efficiency. And when you're running a job site, for example, the digital twin essentially creates that information pipeline, I would say, between office and field. So you have data information, and sometimes it's close to real time. Let's say if you scan a structure that has just been completed, like the concrete has just been poured, a surveyor is doing a scan to see if the structure is actually according to plan. And then, as close as possible to real time, you want to be able to inform the next concrete truck that now it's time to pour the next level or next layer. So this is where you want to have that very close loop information.
Yeah, so I can see that. I've heard people say concrete waits for no man and no woman. It needs to be poured then. So that would make sense to me. Where else do you see this technology being applied? Is digital twins something we can like copy paste into other verticals, into other industries, or is it just like now? Is the focus simply on building and construction?
Well, our focus certainly is on, let's say, building construction, but you could also transport that over into agriculture, into forestry, which are areas that Trimble is active in. I certainly have a tie to forestry myself, and you would want a digital twin of your farm field, of your forest as well. The data density from a timing perspective wouldn't need to be as high as in a construction site, I would say. But even there, on a farm, the latest developments in satellite technology, for example, are now enabling us to do quite more sophisticated things that were able or that were possible 10 years ago.
So you mentioned data density before, and during the conversation we were talking about these enablers, these things that are making this kind of stuff possible. Is digital twins this kind of infrastructure? Is it a response to the data density that we're seeing? Like, is this something that it's almost a self-fulfilling prophecy that we need to do things like this because we are collecting more and more data, or is it more the industry saying to us, "Hey, we need more information"? Because I could see this going either way, personally.
Good question. What was first, the hen or the egg? I would think it's driven by wanting to have more real time information that drives the data, and then again that enables more information to be generated, more decisions to be made, which again drives more a higher need for data. So I would think it ends up being sort of a feedback loop where you have more data leads to more insight, leads to more request for data.
When people come to you, like when you're working with customers, clients, do they mention digital twin? Is that what they call it, or do they call it something else?
Digital twin is mentioned. One term that we see or hear or use is basically a real-time geospatial data model. Customers are also asking essentially for the things a digital twin enables. Like customers are looking to be able to collaborate on a job site or on data. They're looking for improved efficiencies around their processes, and a digital twin is the right method or the right tool to enable that. So they won't necessarily ask for digital twin, but they might ask for, hey, I need to be able to collaborate on a job site to make decisions in real time, to predict how my resources are allocated, and a digital twin happens to be the right tool to do that.
The reason I ask that is because oftentimes I feel like we get into a semantic argument with within the industry and externally from the industry as
Hmm.
well. And it feels like, in Danish we would say, we're talking past each other, that we're talking about the same things, but because we're using different words for them, nothing happens because we don't know what the other person is asking for. We're saying digital twin, they're saying, I want to make a decision in real time. I want to stream some data from here to there and turn it into a door or something. And so I was just curious to hear your perspective on that.
So yeah, I would say the digital twin is a means to an end, and the actual ask from the customer is more around efficiency when it comes to managing resources, when it comes to managing facilities or running a facility, for example.
I think that's a great way of saying it, a means to an end. Oftentimes, I feel like within geospatial anyway, and I'm definitely fall prey to this all the time, is I get really excited about the technology, but I need to keep reminding myself that the technology is the medium, it's not the mission, and the mission is to do something else. And I oftentimes have to look up and say, okay, right, the mission is something else. It's not to focus on the technology, is what we're going to do with it, how we're going to help this person get to where they're trying to go. I was again curious to see if you would run into a similar sort of idea.
Yeah, exactly. And I could imagine if you mentioned digital twin to some users or some stakeholders, they might get not confused, but maybe don't really know what a digital twin would provide to them, or what why they would need a digital twin. But if you tell someone that with a building they're purchasing, they could also be delivered a digital data representation of that building, which allows them to simplify asset management, or identify problem areas in the building, or have a database to look back into when doing some kind of remodeling in a building. I think that would provide a whole different context and level of interest on the customer side.
Yeah, totally. I could definitely see that. If you were working in the industry, let's say you're working in CAD, working with CAD or working with GIS or working doing scanning at the moment, and you, and you have all this understanding of digital twins and perhaps where we're going in terms of the future of all this, what kind of advice would you give people? Perhaps in terms of skills they might want to think about, perhaps in terms of career advice, what's going to be a great career path in the future. Is there anything that you could sort of say that would perhaps help us or give us some insight into the things that practitioners might need to start thinking about?
Yeah, as I said earlier, I think a lot of the autonomy aspects will enable things that weren't possible before, especially from a like survey perspective. I would still expect that the majority of survey work will still be needed the same way it is done now. Like we wouldn't send out Spot the dog to survey in a new plot of land or things like that. Having said that, technologies like mobile mapping, for example, certainly do provide a lot of efficiency or efficiency gains when it comes to creating information or asset information, which, let's say, 10 years ago maybe was manually collected in the field. But again, that would also open up new opportunities, especially when it comes to things like that online collaboration on data which is centrally located. One of our customers that I interviewed on how they see the workforce of the future, the feedback was that they want their future workforce to be able to work from anywhere on any device and still be able to collaborate on the same data, no matter whether they're in a coffee shop or in an office. So, from that perspective, I think it also opens up a lot of opportunities for a more flexible work, a more, let's say, diverse work.
That's interesting that that collaboration comes up again and again and again, which makes sense. When I think about collaborating, like with you, for example, on this interview, the amount of back and forth that we had to go through just to organize a time to talk with each other was quite amazing. And so this is just for a simple conversation that I'm talking about now. But when I think about that in terms of making huge $1 billion decisions, perhaps that need to be, and these decisions need to be made within a very specific time frame, you could see how collaboration all of a sudden becomes extremely important.
Yeah, and at the same time, look at how much time and effort it would have taken us 20 years ago to have that same interview. I probably would have hopped to a plane, or you, and we would have met somewhere in person. Now it still takes back and forth, but it is a much more natural thing to do it virtually and to collaborate in a virtual environment. Now, if I look at Trimble as a company, how we collaborate, my team is distributed between Colorado, New Zealand, and Germany. My direct manager is based in Melbourne, and we collaborate very efficiently on a daily basis, and it's second nature to work.
Is there somewhere we can go where we can see this in action? Like, do you have like a demo on your website somewhere? Do you have an interface people can go and look at and see? I think that might be really useful for people that are interested in knowing more, perhaps.
Yeah, one example that would provide you a first glimpse into the digital twin world, I would say, could be Trimble Clarity. It's a point cloud streaming solution which is entirely hosted online. You can upload a point cloud, you can upload a SketchUp model, and personally, I used it, for example, to create, let's say, a very basic version of a digital twin, not so much real time, of our own house that we used to own in the US. So we did a laser scan of the house, uploaded it into Clarity, then created a SketchUp model, uploaded that, and there you had basically a rough digital twin of your own house. You could look at the data, and it's accessible to essentially to an end customer, end consumer, with, in that case, freely available tools. You can upload any LAS file, which is standard point cloud format, and you could even scan a room, for example, using an iPad with that technology. And then again, SketchUp allows you to model and upload that into that solution as well. So you can combine point clouds with a SketchUp model and look at that data. You can do annotations, measurements in that environment. I wouldn't claim that ends up being a digital twin because it's not like real time maintained, or maintenance would be via the user updating it on a regular basis, but it gives you a good insight into what's possible.
It's interesting that you say that we could upload a scan. So this makes perfect sense to me. Let's say we're using an iPhone with a LiDAR on it. We scan a room, we scan something, we upload that. But then you talk about creating a SketchUp model, so a line-based model, I guess, and then uploading that, and then those two things are combined. Is it not possible to create that model from the scan?
That's possible, just not with easily or freely available tools.
Okay.
So if there is an extension to SketchUp which allows you to model along point cloud and create a much more accurate representation using a point cloud as input, but that wouldn't be as easily accessible to our audience here.
Well, Gregor, I really want to thank you for your time. It's been a pleasure talking with you. It's been kind of eye-opening talking to you, actually. I really appreciate the conversation. You've given us a link that we can send people to. That was Trimble Clarity. I'll get the link off you later, put it in the show notes. Is there anywhere else people can go to if they want to reach out to you personally, ask questions, or if they want to find out more?
Well, I can be found on LinkedIn, certainly, and can share my LinkedIn profile or link. The Trimble website certainly provides a lot of insight into what's going on the geospatial side, on the Trimble construction side. Those are probably the best areas to find me.
Thanks very much for your time. I really appreciate it. Cheers.
All right. Thank you so much.
So I really hope you enjoyed that episode with Gregor. As always, there'll be links in the show notes to places you can connect with him. And I also put a link into the Trimble Clarity tool that he mentioned. That might be interesting for some of you to play around with. There's a few other things I want to mention here at the end. So during this conversation with Gregor, he mentioned something along the lines of the construction industry being behind in terms of compared to the manufacturing industry when we think about digital twins. And a long time ago, I published an episode with a company called SensorUp. And if you're interested in what people are doing with digital twins and geospatial and the manufacturing side of it, this would be well worth checking out. So it's also a conversation about the Internet of Things, about a really, really interesting positioning device, or positioning technology, I should say. And this might be the first time you run into a standard called the Sensor Things Standard, which is interesting in itself. So this is a standard way for the Internet of Things, the sensors that are going to be involved in the Internet of Things to communicate with each other. So that's worth checking out. I'll put links to these things in the show notes. So I just want to quickly mention a few other episodes that you might be interested in. There's a really interesting episode about augmenting reality. There is a couple of great episodes around cloud native geospatial and some of the tools that are being built. I often refer to an episode about Google's BigQuery geospatial engine, Google Earth Engine, and the Microsoft Planetary Computer. I'll put links to all these in the show notes, but if you haven't listened to them already, even if you're not interested in using those things, listen to them and think about what the infrastructure looks like, what they are building these systems based on, and the architecture of them. It might also be worth checking out an episode on PDAL, so PDAL, so the Point Data Abstraction Library. Or one of the really interesting things that the guest in this episode, Howard Butler, mentioned was he looks at point clouds as being a third type of geospatial, so vector, raster, and then point clouds. And there's been some super interesting work done around streaming point clouds, and you heard Gregor mention that as well during this episode. But the episode around PDAL would be worth checking out. It'll help sort of fill in some of the blanks, I think. Okay, that's it for me. I really hope you've enjoyed this episode. I'll be back again soon with a new episode for you. I hope that you take the time to listen then. As always, you're more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter. There'll be a link to my LinkedIn profile in the show notes of this episode, or send me an email. You can reach me at info@mapscaping.com. I would love to hear from you. Okay, that's it for me. We'll talk again soon. Bye.